Good afternoon, everybody. Good afternoon, all of you. Today, now we'll be starting the second unit. First unit, I have covered all the important topics, and Saturday we had a discussion on the summary of whatever we have discussed. So, the first unit describes various services that operating system does. One among those services is process management, and second unit completely deals with process management. Okay, the first unit we have studied in general about what is operating system, why do we need operating system, what are the services offered by operating system, okay, and what is the structure of operating system in general, and so on. The second unit we will be studying only about process management by the operating system. So let us begin with what is a process. Last time, the previous class, in the command prompt, I typed task list and you saw a list of process that is happening, right? Yes or no? So what do you mean by a process? Process is an instance of a program. That means you have a program there and you are running only one particular instance of that program in the OS. This is called as a process. Okay. So this is a definition for process. Process is an instance. Process is an instance of a running program. It includes the program code and its current activities such as register values, memory allocation, open files, operating system. So the operating system manages the entire process by allocating different process IDs to each process. Okay. So a process is a program in execution, and there is a difference between a process and a program. A process is a program in execution and it is not the program as such. Okay, from the point of view of an operating system, a program is any executable file, say for example like a.out in Unix or .exe files in Windows. Whenever you create a file, it will be like .exe. No? .exe are executable files in Windows. When you double click that, what happens is that some process is being executed by the operating system. Say for example, word.exe is a file. When you double click that, the Microsoft Word or something opens, right? So it is an exe file. Now what is the difference between the process and program? So by definition, a process is a running instance of a program, but a program can be any executable file that is stored inside your disk. The process keeps changing, whereas the program you are doing nothing now, so it will be like that itself, right? Program is an executable file which you are not running. Only when you double click that program, what happens is that it becomes a process is being initiated and the program works based on that. So you should be very sure about what is an instance, because you are going to study so many areas where you need to use the instances of objects. Whenever you study object oriented programming and so many other aspects, you need to understand what is an instance. Instance, say for example, if we say student is a general structure, okay, Abhilak is an instance of student. So one student is an instance. So that is the difference between the process and the program. Program can execute you can open two Word documents at a time, right? There are two different processes. But Word.exe is only a single program. Understood? So it exists in memory only for a short period of time, and process, once you have typed the data, you're closing the Word document, the process ends. But the executable file is not like that, it will be there forever. So these are the major differences between processes and programs. So I told you process is a state. What are the different states of a process? Different stages of process. So I told you now, when I am clicking a executable file, a process is initiated. And the process, we have different stages or different stages, it crosses one after the other. The first state is new, that is when a new process is created, the first thing happens is this process creation. Second thing is that it will start running, right? The another stage is that it will wait for the process, because say you are giving a print, already one printer is going on, one printing is going on. What happens? It keeps waiting, right? So another stage is waiting, another process is ready, the process is waiting for to be assigned to a new task or a new process, and then we close the process. So whenever a process is being initiated, whenever you run a program, whenever you double click a program or whenever you run a program, what happens is that a new process is created first. Okay. After a new process is created, what happens? It creates an instance. It starts running the process, right? Running of the process. After the process is running, what happens is not process is running. Another type of process state is that you're opening a Word document, you're giving an printout. Your printer is already engaged and doing some other business. Is printing somebody else's letter. So what happens? It keeps waiting. It keeps waiting for a device. For example, I told you printer, it is an input output device. So you have a instance of waiting, a state of process waiting for something else. Could be a processor, could be an input output a device or something like that. And then the next process is that it gives you a signal that the printer is ready for, and it can start printing. So it can print it. And after that, what happens? It gets terminated. Okay, so these are the different states, or what you call, in other words, different stages which a process comes across. So this is a sample flow chart of how a process begins and how a process is terminated. Next point is about process scheduling. So process scheduling means you are fixing a particular time slot. Scheduling means what? Say you are having your exam schedule from 5th onwards, right? That means you are given a time slot where you are supposed to be there and do the particular job. In process scheduling also, what we do is that the operating system allocates particular time slot for each of the process to get executed. Okay, so this is called one of the important goals of multi-programming. So what are the jobs that it has to do while scheduling? It has to see, it has to make sure that the CPU time is optimized in such a way that it is used continuously. There is no wastage of resources and time. Okay, so that is what is the objective of multi-programming, because we will have multiple programs operating at the same time. So we'll be using scheduling, we'll be using different kinds of algorithms to schedule different processes, and these are called as scheduling algorithms. So time sharing systems which switch CPU between processes quickly so that the users can interact smoothly. When a user is doing, no, he should not know that is allotted only particular time slot. Okay, this is so fast in micro milliseconds. It keeps allocating for different multiple processes. The process scheduler selects the process for execution on the CPU. Okay, in a single processor system, only one processor runs at a time, and what happens is that the others wait for the processor to become free so that they can do their job. Okay, so imagine that a process scheduling is like something like you are waiting in a TV or you are waiting in a railway counter to get a ticket or in a counter to get a ticket. So the one who is giving the tickets are scheduling the processes, right? They're giving you one by one. Okay, this person is not at all idle. There is another person coming in, he's being utilized there. Understood? All of you. So what are the different steps involved in scheduling? First, it has to create a job queue so that the next person joins in immediately after the previous one. So how is the process governed? First, first we have a job queue, right? So what happens is that all the processes are kept in a queue one by one and it is being numbered. Then ready queue contains the processes that are loaded in memory and waiting for execution. Device queues. Each input output device has a queue for the process waiting for it. Okay. So this is how the scheduling works. Scheduling has three types of queues. One is called as job queue, ready queue, and device queues. Okay? Three types of queues: job queues, ready queues, and device queues. Okay? So next, what happens to different processes? How a process is scheduled. When a process is executing, you may have a request input output and move to an input output queue. We have seen that we have a device queue, no? Create a child process and wait for its completion. Be interrupted and move back to the ready queue. So as soon as the process is initiated, the second stage is running stage, right? So when it is getting executed, what happens is that it can request, these are the possible things can happen. You're double clicking Microsoft Word, it is getting open, and then what happens is that now you're giving control P or you're giving something to the printer. What happens? It can request an input output and make an input output queue. You can see that the printing queue will be there, right? Process 1, process 2, process 3, and so on. It can create another one child process like a request and wait for that child process to complete. Okay. So in Word, if you suppose you wanted to insert an image, there should be another dialog box that opens, right? That box is called as a dialog box. In that, you can select your image and put that image in your document, right? Have you all used it? And the other option it has is that it can be interrupted. You can stop the process and go for the next one. Okay. So what is process schedule life cycle? So life cycle means from birth to death. Okay. Life cycle now. What life cycle means? Life cycle is from birth. Anything we call it as a life cycle because it starts from birth and ends with death. So in a process, what happens? We'll start from how the process has been started till the process has come to an end or terminated. So this is called as life cycle. Process scheduling now. How you are scheduling a process from its birth till its death. So birth means a new process is created, then ready, queue, then CPU scheduler, it picks the process, it does the process runs. When process runs, this process can request for an input-output operation or can be moved to another one, queue, where the input-output is in queue, right? That means when you double click a Word document or Microsoft Word or something like that, what happens is that the process is created. When you give something else, it starts working with the process. When you're typing on that, it starts working with the process, right? Then what happens when you're giving, for example, a printout or something, it goes for another option where it has to wait for an input-output queue. Okay? It can, otherwise it can do what it can do. It can create a child process. Like I said, insert an image. When you click insert an image, what happens is that another dialog box or a child process is initiated. Okay, then what it can do, it can wait for the end of the child process. And finally, the process is terminated and everything, all the queues and everything is being removed and cleared. Okay, is that clear for all of you? So we'll deal in detail with what are the different processes and how process is created. Let us see the operations in processes for an operating system. Begins with process creation. A process is a big one. You have child process, a parent process which initiates another process which is inside the same process. Okay. This forms a parent-child relationship, creating a process hierarchy. Hierarchy means from top to bottom, what are the things that is going to come. Okay. So first we have a parent process. So from parent process we have a child process that is created. Okay. This child process can inherit resources from the parent. System calls like fork in Unix creates a new process. In Unix, we use the fork command to create new processes. So first operation is about its creation, process creation. So now, see, you can fetch good marks if you underline important points in your exam answer sheets. Okay. So how I'm going to help you in that is that I'll be giving some kind of hints like this, which you can use to emphasize in your answer sheet so that you get better marks and clear the exam. So most operating systems like Unix, Linux or Windows identify a process using a thing called as process identifier or PID. So whenever you initiate a process, there is a ID for the process that is called as process ID. Okay. Every process will have an ID, process ID, and this process ID is used to find out the identity of the process. In most cases, it is an integer number, okay? PID 1, PID 2, PID 10, PID 25, PID 1 lakh, and so on, right? A new process is created by, for example, fork command in Unix. You cannot create it, it is done automatically, okay? After a fork, system call one of the two process typically uses exec system call to replace the process memory space with a new program. Okay, so I've given you an example. I'll show it to you later on in practice how these are created. Okay, so for command is used to create a process. An example here. An example here, when you open a web browser, it starts multiple processes. For example, UI rendering, networking, and so on, right? When you double click the Google Chrome or whatever is the browser, it opens, right? When it opens, what happens? How it is opening? It is a process ID is created. Multiple processes are created at the same time. It is contacting the internet, the outside world, okay? It is displaying the images. So these are all the operations that happen when you initiate a process. Steps in process creation. You can assign a unique process ID to the new process, allocate resources, the CPU time, and so on. So as soon as a process is created, these are the things that the operating system does. First, it allocates a ID or number is there. Okay. As soon as you enter your college, what you are given? You are given an ID card or a roll number, right? Registration number. The same way, whenever a process is started, a registration number called as process ID is given to that particular process. Clear? That's one thing. Second thing is that you will be allotted particular classrooms, right? You have to go to this class, you have to do this one, right? Same way, allocation of processor time for each of these processes. Eh? Understood all of you? Then initialize process blocks. Initialize process control blocks with details like process state and program counter. And the new process to be the ready queue. Okay? Are you all able to understand what is being written here and what I am speaking? So there is a process control block. Once you create a process, this process control block is being initiated. The next step is about termination of the process. Termination means coming to an end, closing this process. So a normal termination, process finishes execution. Abnormal termination means it is due to some error in the process, it is getting confused, the program is not working properly, you have an abnormal termination. Killed by another process. Forced termination by operating system. When another process takes force, the other one, the previous one gets affected and it gets stopped. Operating system makes or compels the process to end. That is called as forced termination. Next is all about inter-process communication. When you have multiple processes initiated by the operating system, you will have these two processes and you will have several situations where one process needs to connect with the other one. Okay, this is called as inter-process communication. It is a mechanism that allows processes to exchange data and coordinate actions. Processes can be independent or cooperating. Inter-process communication is crucial in multitasking and distributed systems where multiple processes needs to work together. When there are so many processes and these processes should work together, is called as inter-process communication. So this is the comparison between two types of inter-process communication. One is independent, the other one is cooperating. Okay. When there is no dependency of one process over the other, it is called as independent. That means if it is not affected by the process. One process is independent of the other, it is called as independent. That means there is no relationship between multiple processes. A process is cooperating if it can be affected the other way around. When one process requires the help of the other process, it is called as cooperating processes. So these are the several reasons for providing an we need to provide an environment where everything works in cooperation, right? These are the several reasons. We have 4 reasons. The first reason is information sharing. Whenever you are sharing information on multiple processes, one program can have some benefits which can be used by other programs also, right? Processes also. So inter-process communication will help sharing of information and helps in the process getting completed very soon, or helps in the successful completion of the processes. Computation speed up. So naturally, when you have multiple processes working at the same time and different processes are using different timelines, it naturally makes the speed much higher, right? It makes it much more easier so that the computation speed increases. Fast. The next 2 advantages. First one is that it becomes modular, right? Because it is divided into pieces, modules, and each module will have its own working, right? The final one is convenience. So these are the 4 points that we need to remember, the advantages of inter-process communication. So with this, we'll be coming into the conclusion of today's class. In this class, we have studied what is process and what are programs. We have compared processes and programs. We have studied process states. We have studied process scheduling. We have studied process operations. We have studied inter-process communication. Okay. So these are some questions that are available, and these questions are important questions that appear for your exams. These are some of the questions, and answers to these questions will be your. So any questions from anybody? So thank you all. Thank you for listening to me. Thank you very much.